probability of error, the probability of happening becomes close to 0, while basically the average or NP equals a constant. Then in this case, we ask questions, or we answer questions of the sort of, if I have t seconds and I ask the question of what is the probability that I have k arrivals or more or so. And we have also solved several questions. Today, the objective is to study some continuous time distributions. Mainly, we will study the uniform, the exponential, and the Rayleigh. And then we'll start the introduction of the conditional probability. The conditional probability when you have random variables. The conditional distribution, the conditional density functions. This is what we'll do today, inshallah. Okay, so uniform distribution. First of all, this is the first continuous time. Until now, we have talked about continuous, discrete time random variables. This is a continuous time random variables. This is the first one of them, uniform distribution. Uniform distribution is a distribution or a random variable which is defined over a specific period of values from A to B. So the random variable can take only values from A to B. Before A, it's impossible. Larger than A, it's also impossible. Okay? And it's equally likely that the random variable takes any value between A and B. And because of that, we call it uniform, from the name uniform. So it's uniformly distributed, which means equally likely to take any value between A and B. And we discussed this when we talked about the wheel of fortune. When you spin a wheel, and if this is numbered as A, this is numbered as B, and you just record the time, the place at which it stops. And we said that, okay, what is the probability that it stops here at this point? Shiva?
0.
0, right? Because it's 1 point over infinitely number. However, what is the probability that it stops here or below, before?
1/4, I think.
1/4, because you count what is the range from here to here and divide it over the total range. So it's 1/4. So if you look at fx of x, which is the probability that x is less than or equal to small x, then as you increase x from minus infinity up to before A, sorry, the probability that x is less than or equal to this number is 0. Once you cross A, the probability starts to increase linearly. So for example, here, if this point is C, so C here, the probability that x is less than or equal to C is 1/4. Now, if this point is D, so what is the probability that the random variable is less than or equal to D? Shabab? Shabab, what is the probability that the random variable takes values less than or equal to D? So here or before? Half, right? Because it's half the range, and so on. So if you plot the CDF, it will look like linearly increasing from A to B, and then it will saturate. If you ask you, what is the probability that the random variable will take a number that is less than B? So that is less than H, where H is larger than B, here H. We know that if we spin the wheel, the probability, you can always get a number from A to B. So the probability that you get a number less than H is what?
1.
1, right? And so on. And now if you differentiate this CDF, you get this PDF, which basically takes it as a uniformly distributed random variable. Now mathematically, the CDF looks like linearly increasing for x values between A and B. Linearly, so it's x minus A divided by B minus A. Before A or less than A, it's 0. Larger than A, it's 1. For values x larger than B, sorry, it's 1. And differentiating this, you get basically the CDF, which is uniformly distributed. It's equal value from x between A and B, and it's 0 elsewhere. Well, of course, B is larger than A, and A is a finite number. We encounter such random variables when you have quantization. Those of you who have taken 370, you know that when we quantize, this is in electrical engineering, this is in the Wheel of Fortune, but when we quantize a signal, okay, what we do is we approximate its value to the middle range. So if the signal has a value, a sample signal has a value here, we only allow certain quantization range. So the quantization error, this signal can be here, here, any place, but you will always approximate it as the center, which is here. So the quantization error, which how much you lose out of this, the original value, is what we call quantization error. And this is modeled as a uniform distributed random variable. Okay. So if I ask you a question, for example, or an example, find for random variable uniform between 0 and 5. What is the probability that x less than or equal 1.5? شباب. What do I do? شباب.
0.3.
Yeah, what do I do? I integrate the PDF from minus infinity to 1.5, right? The PDF of x of x. Now I know that since I gave you its uniform, I know that fx of x equals what? 1 over 5. Why is it 1 over 5? Because this area under the curve has to be area equal to 1. So if it is between 0 and 5, this has to be 1 over 5. This is only from 0 to 5. And it's 0 otherwise. Right? So if I integrate this from 0 to minus infinity to 1.5, then as if I'm integrating a constant number from 0 to 1.5 dx, which gives me the same constant number with x integrated from 0 to 1.5, which is 1.5 minus 0 divided by 5, which is 1.5 over 5.3. Right? This is the way we look at the uniform. To always go to the definition. Now, if you have the CDF, you can write it directly, fx of 1.5. But if you don't have the CDF, you need to calculate it. Okay? Now, if it is, I gave you the CDF, so I need what? I need only to substitute. So it's x minus a. A here is 0, so it's 1.5 minus 0 divided by b minus a, which is 5 minus 0, which is again 1.5 over 5, which is 0.3. So either way, using the CDF or using integrating the PDF gives you the same answer, because the CDF and the PDF are related according to the CDF is integral of the PDF. Any questions, Shabab, about the uniform distribution or random variable?
Clear, doctor.
Now, the second distribution that we'll talk about today is the exponential distribution. Exponential distribution is defined as follows. Its PDF looks like this. It's 0 for any value less than a, so it cannot take values less than a. And at a, it increases. Sorry. The PDF becomes 1 over b and then decays exponentially. And this is why we call it exponential. So it decays exponentially. Okay, this is why we call it exponential distribution up to infinity. So it can take values from a to infinity. And the PDF looks like mathematically for values x larger than a, it takes this function. It's 1 over b e to minus x minus a divided by b. And it's 0 for any value x less than a. Okay? So the a here is the place at which it starts to become non-zero. So it's the shift. While the b here, we call it the average value, اللي هو المعدل, المين. Okay? So now as b increases, for the same a, as b increases, ايش رايكم? It will be more steeper or it will be a more smoother PDF. Larger b. يا شباب, what do you think? Larger average. Be like this, or it will be more like this?
It will decay
Steeper.
faster.
It will decay faster. Larger b. It will decay faster ولا slower يا شباب? Larger b means the product that we multiply this with is a smaller number. So it will become like this. And the average becomes larger. Larger b. We say that it's larger b. Okay? This is for smaller b. This is for larger b. So this is the effect of the average. As you can see, this is wider, larger b wider. It means that the average is somewhere here. Why this is a smaller b, it means that the average is small. تمام يا شباب? This is the effect of b, which is the average value. Now, the CDF, if we integrate the PDF, it will look like this function. Again, it's 0 less than a, and it increases with 1 minus an exponential until it reaches 1 at the end, to infinity. And because of that, mathematically, it's 0 before for any value x less than a, and for values larger than a, it is given by this function. Well, again, a is the shift here, at which it starts become non-zero. So the distribution here is defined, x here is defined for a to infinity. While in the uniform, x was defined over a to b, which means that any value less than a for the exponential it's an impossible event. It has a 0 probability. It's impossible. Now this exponential distribution is used to model the fluctuation of a radar signal, or the power also used to model power received in wireless communication. The power of the signal received at your mobile most likely has an exponentially distributed random variable. تمام؟ Shabab, exponential distribution clear? We'll take an example in a minute. But do you have any question about the parameters? The shape of the PDF, the CDF, what does it mean? Application. Any سؤال? Okay, so an example. If we take this as P is received by radar from an aircraft, it has this PDF, very similar to what we defined, except that it starts at 0. Okay, so basically the PDF looks like this. At 0, 1 over P, 0, and it goes to infinity. Sorry, P. The whole thing is P here. This is P, small p. Okay. Now, we can see that B0 here is the average value, as you have average received power, as we have defined it from this PDF. Now, the question would be, what is the probability that the received power is above the average? What is the probability that the received power is above the average? And we know that the average value is equal to P0. So it's an exponential value, it's exponential PDF with A equals 0, which is the shift at which it starts, and B equals P0. So the PDF looks like this. So it looks like this. And now the probability that P is larger than the average, it's equal to the probability that P is larger than P0. And we want this. We are asking, what is the probability that the received average power is above the average? We want this to be equal to 1 minus the probability. This is equal to 1 minus the probability that P, the received power, is less than or equal P0, which is 1 minus the CDF evaluated at P0. Now, the CDF evaluated at P0 is 1 minus E to P0 divided by P0 from this CDF that we know before. Now, 1 minus 1 is 0, and you end up with E2 minus P0 over P0, which is E2 minus 1. And this is equal to the probability. So if P0 here is the average, it's the average value, معدل, then the probability that you are above this average value is small. It's 0.368. What does this mean, Ishma? It means that if you are receiving a power at your mobile with this distribution, then the probability that, which has an average value of P0, then the probability that your signal is above this is this number. It's 36% of the time. It's not even half. And because of that, exponential distribution is not a good distribution. And because of that, in wireless communication, you have to deal with this in a very serious manner. And there are many, many ways to improve the received signal. يعني في الجاوسن لو تتذكروا الجاوسن the probability, this probability was equal to كم in Gaussian. شباب, the probability that x is larger than its average value. تتذكروا كم كان average value? AX.
Okay.
AX.
It was half or something like
Half,
that.
right? It was half.
Yes.
Why? Because it was, this is average value. It was half. Why? Because it has, the distribution was symmetric. It was symmetric. Here, the distribution is not symmetric. It's skewed. This is a skewed mile towards the left. So it's focused more towards the left. You can see that. probability is focused more at values less than P0. And this is what makes the probability that you have low value is a large probability. So here, if we ask the opposite question, what is the probability that P is less than or equal the average value? Then I the average value 1 watt. What is the probability that I receive less than or equal 1 watt? ايش رايكم؟ Send me over the private chat, شباب. What is this probability equal to? Over the private chat. يا شباب. Send it. I only received few.
Can you repeat, Doctor, the question?
This is the question. What is the probability that P is less than or equal P0 in this example? What is the probability that P is less than or equal P0? I have been looking at your answers. Yeah, most of you have done it correctly. This is basically, and some of you had some mistakes. Now this is equal to, you can solve it using the integral from minus infinity to P0, right? And solve the math. Or you can use what we have already solved. This is equal 1 minus 0.368, which is the one that we just find here. Why? Because this is the probability that P is larger than P0. The probability that P is less than P0 is 1 minus that, which is 0.632.
632.
Exactly. So if you receive a wireless signal, then the probability that your signal is below the average value is 63% of the time. 2/3 of the time, your signal is below its average value, which is, as I mentioned, it's a very bad situation if you are dealing with such communication system. Any question? The last continuous time, continuous random variable. Did I write continuous time? There's no continuous time, continuous random variable. Continuous value. Not time, there's no time here. The last continuous random variable that we'll talk about is the Rayleigh distribution. The Rayleigh distribution looks like this. Again, it's important in the wireless communication system. Now, the Rayleigh distribution models the amplitude of received signal in wireless communication. The amplitude, not the power. Okay, this is just a point to worry about, to look at. So now the distribution looks like this. First of all, mathematically, it is written as this. And this is the CDF. These are the mathematical values. However, it looks like it starts again at A. So anything less than A, it's 0. And it goes to infinity. Okay? This is X. Now, its average value, or sorry, its peak value at A plus square root of B over 2. This is the peak value. And it's equal to 0.607 square root of 2 over B. So these are not for remembering, just to know I would like to understand the characteristics of this distribution only. Okay, so basically you can see that again most of the probability lies in the less than the average value. And the CDF looks like this. From A, before A it's 0, so it cannot take any value less than A. And from A to A plus square root of B over 3, B over 2, it's almost 0.4. And after that, it continues up to 1. Again, the Rayleigh distribution is a distribution that exists, and it has basically many applications. One of them is the amplitude of the received signal in wireless communication. طبعا we don't expect you to remember these equations. مثلا هذه ال fx ال PDF or CDF. لكن for the exponential you need to have it in your mind because it's very simple and it's very famous. نفس الشيء الجاوسيان، نفس الشيء اليونيفورم، البويسون، binomial. كله you need to understand and you need to know the equations. For example, the PDF, the CDF, the PDF of the Poisson, the PDF of the uniform, and so on. The CDF, you can always get it from the PDF by integration. But for the Rayleigh, you don't need to remember this. Not for remembering. Recalling it. Not for recalling. Same both. أي سؤال يا شباب؟
Doctor, yes, I have a question.
تفضل.
If B in the Rayleigh distribution is the variance or lambda sigma square, isn't it a two normal distribution?
لا this is not a normal distribution. لو تلاحظوا هذا ما هو symmetric, not symmetric. تمام. We will talk about the variance later, about different random variables in chapter 3. The variance and the average, how to find it and so on. But this is not a Gaussian distribution. وشكله كده قريب من الجاوسيان. الجاوسيان goes to infinity, minus infinity and infinity. And it's symmetric. This is not a Gaussian distribution. This starts at, لو تلاحظ at A. Starts at A. قبل A it's 0. تمام؟
Yeah, yes.
Other questions? Okay. So let's have an example about the median value for Rayleigh. The median اللي هو الوسيط بالعربي. الافريج هو المعدل والميديان هو الوسيط. It's defined as the value of x for which the probability is 0.5 that the value of x does not exceed the median. يعني median is اللي هو الوسيط اللي هو the probability that you have or basically half the values of the random variable is above this median, half, and the other half are below this median. تمام? The median is the value of x for which the probability is 0.5 that the values of x does not exceed the median. So the value x0 such that the probability that x less than x0 equals the probability x larger than x0. هو اللي يقسم ال probability في النص. Now x0 here is the median value. تمام؟ This is different than the average. الaverage هنتكلم عنه في التفاصيل chapter 3. But this is not the average. Okay, it's the value at which half the probability is above, half the probability is below this value. Or half the values of x is above this value, half the values of x are below this value. In order to find the median, simply we need to find the probability that x is less than x0, which is fx0, and we equate it to 0.5. We know fx0, I just put or substitute for x0, and we equate it to 0.5. And solve for x0. If you solve for x0, you will find that this is equal to this. تمام. What is the median for Gaussian distribution? شباب. What is the median for Gaussian distribution? With a, x, and sigma x squared. نعم.
I think it will be the average value.
Yes, it's exactly the average value. Thank you. Only for Gaussian, only for few random variables. Now let's take the exponential. Let's calculate the median for the exponential. What is the value? What is the probability that x less than or equal x0, and we equate it to 0.5? Find x0. This is the way we find the median. Median of p, which is exponential. Okay. What is the probability here? It's 1 minus e2 minus x0 divided by p, 0. We equate this to 0.5. Okay. Now we take the 0.5 here, we take the exponential on the other side. So we have here 0.5 equals exponential of minus x0 divided by p0. If we took the log, it will be ln, 0.5 equals minus x0 divided by p0, which means that x0 equals kam? Minus p0 ln of half. Or if we remove the minus and we remove the half, it will be p0 ln 2. p0 ln 2. ايش رايكم؟ ln 2 is larger or smaller than 1? شباب. Smaller than 1, right? And because of that, the median is here. So this is x0, the median. And it will make sure, it will basically divide the distribution into two halves. The area here is, the area less than x0 is half, the area above x0 is another half. تمام؟ Median. طيب, any other questions? طيب, now, until now we talked about many random variables, and we defined already the distribution and the density function. We said that this is equal to, or called, commutative distribution function, or for short, distribution, and the density function is for short PDF, which is a probability density function, or density function. Now what we'll do in the coming discussion and next lecture is the conditional distribution and density functions. The conditional distribution and density function, how they are defined, what are their properties, how to find them, and so on. So a conditional distribution and density function, if I have two events, A and B, then the conditional probability of an event A given B, we have defined it already before, right? It's a probability of A given B, which is equal to the probability of A intersect B divided by the probability of B. So simply conditioning that B happened makes the new sample space equals that of B. And because of that, we divide by the probability of B. And we took several examples in that and so on. Now we would like to extend this when you have random variables. Okay? When we have random, the conditional PDF and conditional CDF. What are these? Okay. Now, Given what we know about conditional probability of A given B, let X be a random variable and define the event A to be equal to X less than or equal small x. Then we define the conditional distribution function as fx of x given b, which is probability that x is less than or equal to b to x given b. So this is the condition. B is the condition, and here x less than or equal to x is what we call A. We defined it already. Right? So what I have here is fx of x given b equals nothing but probability of A given b. And I know how to deal with this. Probability of A given b equals the probability of the intersection between A and b, which is x less than or equal x, intersect b, divided by the probability of b. Okay? So واضح كلام؟ Any question? Any question? So if I give you a random variable with a specific distribution, and I tell you, okay, I need a conditional distribution given B, given a specific event. What you need to do is to recalculate the probability that X is less than or equal to small x intersect with B. This will be your new event. Okay? Divided by probability of B. Any question? Let's talk about properties. All properties of CDF apply to conditional CDF. Everything. The first one is fx of minus infinity given b. تذكر fx of minus infinity given b. Sorry, fx of minus infinity كم كانت? For any random variable. What is fx of minus infinity?
0.
0, because the probability that x is less than minus infinity is 0. Similarly, given b, fx of minus infinity given b equals 0. And the way we look at it, this is the proof here, fx of minus infinity given b is nothing but the probability. We always go to the definition, Shabab. Whenever we write fx of كذا, we always go back to the definition. This is equal to the probability that x is less than or equal minus infinity given b, which is the probability that the intersection between x less than minus infinity and b divided by the probability of b. And we know that whatever b is, the intersection with x less than minus infinity is 0. There's no common factor between any event on the random variable and x less than minus infinity. And because of that, this probability of intersection is 0, which gives you a 0 probability. Okay? So whatever the value of b here, b is, the intersection will be always 0. B could be a number, an event that x equal 1. Or B could be a range, the probability that x is larger than 5. Or whatever B is, the event B is, this intersection is always 0. There is no common factor between them. Similarly, fx of infinity given B equals 1. And here is the proof of that. Similarly, we start with the definition. Fx of infinity given b equals probability that x less than infinity given b. And we know whatever b is, x is less than infinity. This is the sample space. So the intersection between the sample space and any event is always the event itself, right? So this intersection probability of the intersection, sorry, equals the probability of b. Divide by probability of b gives you 1. Okay? This gives us, and by definition, this conditional CDF is always between 0 and 1. Third property. And we know that this is so because this is nothing but the probability that x is less than or equal x given b. And we know that any probability is always bounded between 0 and 1. And so on. We can go over all the properties. It's non-decreasing function. As you include larger range, as you include more x's, the probability or the CDF increases. All stay the same. So it's a non-decreasing function. And if I want to find the probability that x is between two values, x2 and x1, given b, it's the same. Conditional CDF at x2 given b minus the conditional CDF at x1 given b. And again, it's continuous from the right. So all properties that we discussed before for CDF apply to conditional CDF. Any questions, Shabab? Are you with me?
Yes, doctor.
واضح?
Yes, doctor.
Any question? Any comment? طيب. The conditional density function of a random variable is the derivative, as we know. So you take the CDF that you found, differentiate, you get basically the conditional CDF, BDF, sorry. If this is continuous, random variable given B, it will be, the PDF will be continuous. If this is discrete, the PDF will be fingers. So if the CDF X given B contains step discontinuities, then this PDF will be basically impulse functions, will contain impulse functions. Very similar to what we have done before. I will stop with the properties. Next time we'll take an example, Sean. So again, all properties of PDF apply to conditional PDF. So nothing is new here. First of all, the PDF is always a positive function. Why is that? Why is that?
Because the probability always positive.
Yes, and because it's a derivative, mathematically, it's a derivative of a non-decreasing function. Derivative of non-decreasing function. This is not a probability function. This is the PDF, Shabab. Okay? A CDF here, a probability function. CDF is a probability function. CDF equals the probability. PDF does not equal the probability. PDF gives you how is this probability of equal 1 distributed among the different values of x. And because of that, the area under the curve of any PDF or the conditional PDF is 1. And the CDF is the integral of the PDF. We know that the PDF is the derivative of the CDF, vice versa. The CDF is the integral of the PDF from minus infinity to x. And if I want to find the probability that x lies between two numbers given b, I need to integrate. So next time, inshallah, we'll go over examples and we'll define the second part of the conditional PDF when we have what we call range conditioning. Okay, inshallah. Type, I am done here. Any question?
Yes, doctor, I have a question, but it's about the attendance.
Yes, go ahead, please.
You don't call us out. Do you use when you ask us questions, is that the way you get the attendance? Because
I have the attendance in Teams. It's automatically already recorded. And I cross-check with your answers. So even if you are attending and no answers, it means that you are not here.
All right,
some students may open and leave or sleep or whatever.
I know, but if I did not answer once or twice because I didn't know the answer and I did not want to embarrass myself.
I mentioned so many times, you need to answer regardless of whether it's correct or not. This is not a quiz. I don't give grades يا شباب على الانسر نفسه. I mentioned it several times. You need to answer regardless you know the answer or not. Say I don't know. عادي. This is not a quiz.
Okay, I see.
تمام. طيب. Time is up. So anybody has a question? Otherwise you can leave if you want. تفضل.
I was wondering about when is your office hour?
Office hour is 2 to 3, Monday and Wednesday. And it's already in the syllabus, inshallah.
Okay.
Okay. If you are welcome to send me anything on Teams at that time. Anytime. Any other questions? Okay. See you inshallah on Monday.